14.
Yeah.
So in 14, we have to figure out, usually the first easy thing to figure out when you're given the graph is your zero line. Now, knowing that my minimum and my maximum is separated by how much? 2. So where's the zero line going to go? At 1. So I know my zero line is going to go at 1. So what's my k value?
Plus 1.
Plus 1. All right. My k value is going to be found by taking the average of the y's. That gives me my zero. Now the a value is how far up does it go from the zero line, or how far down does it go from the zero line? 1. So my a value is also 1. Now I have to make a decision. Do I want this to be a sine or a cosine graph? Which one is going to be less work? Sine. The reason why it's going to be less work is because I started at a 0, and I cycle through 3 times. Now I'm going to go with the sine. Now I got to figure out b. Sir. That's all right. Now, to figure out b, what you do is you take the horizontal distance between your x values of your peak and valley. From 1/4 to 3/4 is how far? 2/4, otherwise known as 1/2. So I know that the distance between here is 1/2. Double it, what do you get? So my period here equals 1. But remember, period in the sine graph is also equal to 2 pi over b. So what I have to do then is take 2 pi over b and set it equal to 1. What's b? 2 pi. So b is 2 pi.
Okay.
So now I have y equals a sine bx, and then it's plus a k. We're not throwing any h's in here, all right? And just write it out. We have sine 2 pi x plus 1.
Wait, can you show me how you found k again?
Well, the easiest way to do it is take your y values of your peak and valley,
So 0 and 2.
add them together, and cut it in half. Get the average.
So the average of them?
Yep, it's always the average.
And you can do that with, okay, so any.
Whether it's sine or cosine, it always works.
Alright.
And then what did you do for the A again?
What I do for a, once I get that k value, that's your zero line. Knowing that sine is going to go from 0 to its a value or 0 to the negative a, how far did it go up? Just went up 1. No.
Could you write the equation like if the 0 line is at 0 and it's shifted up?
If the zero line,
Like how you have the 0 line at 1,
yeah.
could you write the equation as if you had the 0 line at 0 and it's shifted up?
But then that would have raised your peak and your valley, and then that means your zero line would have moved as well. Because the zero line, that k value is always going to be equidistant to your peak and valley. Does that make sense? Yeah. I see where you're thinking about that, but then you have, yeah, it just wouldn't work because then you're becoming a skew off of your peak and valley, which means your k value is shifting around then anyway. Any others on this? 15? Okay, so first thing we're going to do is get our zero line. Excuse me. What's -2? What's the average of -2 and -6? -4. So I know that I have a k value at -4. So I throw that in as my zero line. Is that going to be a sine or a cosine graph? How are you? How are you? Are you sure?
Cosine.
Hey, good luck tomorrow.
Yeah, because it goes to twice.
You're
right?
welcome. I can't. I'm going out of town. I'm running a race, my first race ever. I'm doing the team marathon.
Wait,
Yeah.
where?
Team. I'm running the team marathon down in July. So I'm running like first. There's 4 of us. What's that? Oh. Thanks for your support. I thought you'd be more excited. I got a really cool shirt. I'll show you. Anyway, so once we get this, we're going to make a decision that's going to go cosine because it goes through twice. And then notice if you started at the vertical line, it's starting at a peak or is it starting at a valley? Peak. So is your A value going to be positive or negative?
Negative.
Positive.
What?
Remember, your cosine graph starts at A. So if A is positive, it's positive graph, then it moves its way through.
I guess.
All right, so it's going to be a cosine graph with an A value that's positive. Because how far up is it from -4? 2. Okay? So we have an A value, we have a K value. All that's left is to figure out our period. So how far is it from 0 to 2? 2. So I take 2 and double it, gets me 4. Set that equal to 2 pi over b. What do you get? What's that? Half pi. So your b value
Oh, it goes up by 2. Okay, that's right.
will be pi over 2.
I read the graph.
And that's about as goofy as some of these can get because you start worrying about the fractional values in here, okay? So your b value is pi over 2. So now you fill it out. Y equals 2 cosine pi over 2 x, and then minus 4. Just don't put the minus 4 in parentheses because that way it's not showing that it's a horizontal shift. So sometimes if it's negative, people put it first, be -4 plus 2 cosine blah, blah, blah.
Wait, I'm still confused on how you got pi over 2. Can you do it one more time?
From here, that's fraction equal fraction, right?
Yeah.
Cross multiply. Or exchange on the diagonal. That's all it is.
Alright.
That's all that is.
Well, why'd you do 2 times 2?
Distance between 0 and 2 is how far? So that's half the period. Remember,
Oh,
half the
yeah,
period is
double it, okay.
half the period is between here and here. And then you double it. Yes.
Where did you get the K value from?
Where did I get it from? I got it from the average of our y's. K's here. Sig K.
I did my shift as a -2 and 2 for H and K, and I got the same A and B.
That's fine. I mean, you made it harder than you need to. You don't have to do horizontal shifts in these. That's why I was saying a lot of these with these things. If you go path of least resistance, you won't have a horizontal shift. But you're not wrong.
So K is the average of 2 Y's of this maximum.
Yep. Yep.
Wait, so it has to be of the maximum, it can't just be like multiple of these?
They're going to give you maximum minutes.
Oh.
Yes, they should. Okay. Let's add to this. I've got a couple other versions of this to show you. Okay. Because sometimes, before we get into that packet thing, sometimes you might be given just this. Sometimes you might just be given
plot them?
that. Yeah, and that's the idea here. If they're just giving you a set of ordered pairs,
And it's still has the
yeah, this is the last little bit more time. We had, like I said, on Tuesday, we just ran out of time to do this last little bit. So if you're given stuff like this, the idea here is then to just kind of rough sketch it. Bless you. See how this is working itself out? By plotting it and seeing where your values are going, you're able to tell kind of right away if it's going to be a sine or a cosine graph. How, you ask? It starts at a maximum and moves towards its minimum. If this is going to be your starting point, our starting point, wouldn't we want to just, at this point, it might be easier to do a shift. It might be easier to zero it through. It might be easier to figure out your distances. And there's a bunch of ways to do it. We have enough information here to do this. If you want to go, excuse me, if we want to set it up with a sine or cosine, really. Let's do this. Start with the idea that you have a maximum and a minimum. Let's figure out our period. Okay. What's the distance between pi and 3 pi? 2 pi. The horizontal distance between these two is 2 pi.
4 pi would be,
So our period
oh, period is,
would equal 4 pi, which means I set that equal to 2 pi over b. So what was b? Half. So our b values can be a half. Okay. So far, so good.
Could you complete the other side of the graph and put down a -8 on the other side? Or do you not have enough information to do that?
Well, if we start looking at it this way, we know that you have a maximum and a minimum. If you want to backtrack it, that meant that this is going to cross where?
Zero.
And then it's going to come back down here. Correct?
Yeah.
Wow, this is awfully drawn. I'm sorry.
Not going to scale.
I am now absolved of all of my crimes. Okay. So, a couple ways we can do this. We know that we have a maximum. Oh, let's go with our K value. K value, what's your K?
hold on.
Okay.
Yeah, you can Y.
Zero.
0. It's gonna be 0. Are we okay with that? 8, negative 8?
0.
Okay. So our K value is 0. What's our A value going to be?
8
Now,
plus or minus.
it can be plus or minus depending upon what graph we wanted to choose. Okay. Now, if our maximum occurred at pi and our minimum occurred at 3 pi, if I'm looking at this in terms of a zeroing this out, since our K value is going to be here, that meant that if this was the max, it had to start here to go to the max, to come here, to go down, and to come back up.
Sine.
So what are we going to write this as?
Sine.
A sine graph, because that's going to be easier than a shifted cosine graph. Are we okay with that? That's the idea. Could I have written it as a cosine graph by shifting it over to the right pi? Sure. That's a little bit more work, isn't it?
A little bit.
So why not use the idea that you know that your full period will wind up being 4 pi, and if you know and you remember how the sine or cosine graph works with its oscillation, why not backtrack it and make it go back to that vertical, to go where it hits the y-axis to see whether or not it starts at the 0 value or at an A value.
So,
Okay, does that make sense?
correct.
Okay, you had the worried look, and I'm always worried about that. So we'll go with the sine graph here. A is 8, B is 1/2, and K is 0. Do I have enough information?
Yeah.
Write it out.
So,
So,
would it as a cosine, would the A value be negative then?
if I wanted to do a cosine graph,
Would A be negative then?
A would be positive, because then I'd say it starts at its A value, works its way down,
Oh,
and then it would work its way back up. I'd still say A would be 8, since it's moving its way down, but then I would have said observing X I moved it over, it'd be x minus pi.
Oh,
Does that make sense?
yeah.
But, okay, say it was like a cosine graph, you like shifted over one,
Uh-huh.
then it would start at negative. Right?
From where you went.
Oh,
Like,
what I'm
if
saying,
you took that point, like negative pi, and negative 8. and
oh,
you
yeah,
shifted over
yeah.
one,
Then you
it
could have
would
shifted,
be
then it could have
negative
been an x plus pi, if you wanted to, and have a negative 8. There's so many, and that's what I'm saying, by doing the horizontal shifts, it just opens up to too many possibilities. By all means, go for it if you want. There's no need.
Okay.
Path of least resistance makes our lives easier, go for it. Okay? Heck yeah.
So if it was a cosine graph, then k value would have been +2, or plus pi.
No, the h value would. If you want to shift it to the right, or it would have been it would have been plus pi if you moved it to the left. It would have been minus pi if you moved it to the right.
Yeah, okay.
Okay.
Because it's
And if you moved it left, your a value would have been negative. If you moved it to the right, your a value would have been positive. Too many variables. Path of least resistance. Figure out what happened when it hit the origin. That way you don't have to worry about it. Are you starting at 0 or a? It's just a little bit cleaner. So this would have been 8 sine of x over 2, or 1/2 x. Does that make sense? Let's try another one. I think it's 3 pi. Yeah. So the first one is this is your A. When they write it out A's and B's, this is your max, and this is your min.
So is B always min?
Yeah.
Can you just randomly like draw this?
Yeah, that's usually the easiest way to do it.
Sweet. Try and
You've been going at that thing all day.
And
And yesterday.
At least he's eating something.
I give him credit on that, and I appreciate the sharing. It's very nice of you.
Uh-huh.
yeah, I haven't eaten
He's
turkey
a
for like
snack.
7
But cookie dough like 2 weeks ago.
Yeah, it's better than cookie dough.
No, cookie
His
dough.
brother bought the whole first hour class of chocolate bar yesterday.
What?
Your brother did, yeah.
We brought,
What?
my brother Mark brought $20 to school and brought a bunch of
I
chocolate.
remember
He bought $20 of chocolate bars yesterday.
I spent $40 on cookies at lunch one time.
Who?
That's very nice.
Some
It's like paying it
Maxwell
forward.
kid. He like just bought like $40 of cookies,
Oh, yeah, at
and
the
then
end of the- at the
and then
end-
he got pushed
It's
down,
'cause-
and everyone stole his cookies.
At the end.
Why weren't you there to help him?
I wasn't in that lunch. I got told about it.
Well, at the end of the semester, like if you still have a lot of money in your account, you can't get that back. So you just gotta pay.
Doesn't it
for
roll over the next year?
I don't think so.
Yes.
Well, last time I
Oh,
was
he
asked
brought
somebody
it-
about it, he
mine
was
didn't
like,
roll over.
I
He
asked
brought
Joey
it-
Sasha and he goes, doesn't roll over. So he bought like 14 cookies and maxed out his account and I was like, alright.
No, he brought in
My
actual
account's at
money,
4
like
cents.
$2.20. He's like, I'd like some cookies, and then he got this giant
Is
box.
this what it sounds like when you open your wallet? He goes,
Now it's like when you get a Christmas.
oh,
Open up.
It like snaps.
He's like,
louder snaps.
actually, funny. Weird. I'm not buying anything. Always they are trying to sell shit.
Have a cookie.
I don't have any cookies.
Oh, can I have a daughter? So I
You
can
have
go buy
$5. I need to buy $12.
Cheese balls.
Anyway, what do we do? What do we do first?
Plus.
Come on, get a rough sketch of what it looks like.
I'm gonna go with sign. Maybe. Nah.
Nah, close.
Not sign.
So we start with this one.
Goes in.
First thing is figure out our zero list.
Okay, I got it.
What is 10 plus 4? 14. What's half of 14? 7. So I'm going to put my zero line in at 7. So that gives me a k value of 7. An a value, well, we need to decide which way we're going to go.
3.
Well, we know that this distance here is 2 pi. So that means our period is 4 pi. And it winds up being kind of the same problem we just did. Set that equal to 2 pi over b. And b was half again. All right. So now, do we want to work backwards? We'll work backwards again, and that should end us right here at our 0, because then it would hit it 3 times, which means we're going to use a sine graph.
Which means
You totally guessed.
So our a value is going to be positive or negative? Positive. Our a value is going to be positive, so it'll be a 3. B value of this, so we have y equals 3 sine x over 2 plus 7. That's kind of the easiest way to do it. I mean, there's other ways. If you want to throw in a shift and whatnot, go for it. There's no need to. Yes, sir.
Where would the h go in the equation? The horizontal shift?
It depends on where you want, which way you want to shift it. If you want to say that this is a shifted cosine graph, it's going to move to the right of the vertical, then your h would have been x minus pi, because you went to the right. And then you have an a value of 3. By,
Would you like to choose one?
It would be x over 2.
it would still, you still have the b value still be the same.
b minus
Yeah, it's x minus h. It would have been 1/2 x minus h plus k. That's what it would look like. But by doing path of least resistance, you don't need to worry about the h. Okay. So the other problems that you guys have not done in 14.5 then would be the next page over. I just want you guys to do this first column of them. It'll be 16, 19, and 25.
So page.
This is the next page, so it'll be 866.
865.
866, I think is the next one. And just do these 4, and just tack that onto what you guys did. This is that first column of 4 of them. We'll just add to those other graphs you did the other day, okay? Is that decent enough for those? I don't think they're terrible.
You want to just add it on?
Yeah, that's what, yeah, we'll do that. And then, that won't take you long, but what I do want to spend the rest of the time on real quick is, yeah,
so it's 16.
16, 19, 25.
3/3.
It's just this first column. What I want to spend some time on then is kind of showing you guys what happens with the word problem. I should probably give you one of those though. So, real fast, we talked about this the other day. When you're looking at a sinusoid model, as far as how do you use it via the table stuff in your calculator, think about things that occur annually.
You ever find fossilized one?
No, I have not. Because we drew a Sinosaurus the other day. Think about things that occur like an annual pattern: rainfall, snowfall, monthly occurrences, tides. You know, things that have that period to it. Anything that has this cycle, paddle boat wheel, it's always going around.
Right.
Yeah. So if I'm looking at something here, we're talking about average daily temperature. Daily temperatures, usually in a northern climate, temperature starts low, works its way up, and then it falls back down, doesn't it?
Yeah.
Moline, Illinois,
I hate Moline.
Quad City.
I hate Moline.
Why?
I just hate Moline. I don't know why.
Okay.
Because they're better than you.
No, it's better. They might be better than me. There's probably someone there that's better than me.
Saw a great Pearl Jam concert there a couple of years ago. They played No Code front to back,
Well, I'm
3.5 hours. Awesome. Great show.
If it was somewhere else, if I didn't do it. That's amazing.
Rock Island.
If it was in Rock Island, then it would have been alright.
But not Moline.
But it's in Moline.
East Moline?
East Moline, no, it's still got Moline.
East Moline is such a lovely place to hang out. So anyway, when you see something like that, it should trigger in the back of your mind, it's going to be a sinusoid. L1, L2, and then you put in your Sinosaurus plot. Same idea when we talked about logistic, the log growth ones. Populations. Population growth grows, and what was it, what you calling it, environmental something or another? Carrying capacity. That it hits a certain value, it's not gonna, it can't go past, otherwise everybody just, the dinosaurs will eat you.
The science of
What are you doing?
Trying to
Could
synergize.
you not hum that?
Made that word.
That was like the rest of the summer.
Now,
Yeah, it was.
take a look when you're looking at stuff like this via word problems with sign stuff. I want you just to think it has to be something that runs on a cycle that's going to replicate. Average temperatures, yes, average temperatures. That's why they're average, because it's over a whole bunch of time. It should follow the pattern over and over again. You can use it to predict things. Well, what would be the prediction of something or another?
There was a question like that in the ACT, and there was like, it was hard.
For which one? What was it?
It was a science question,
Yeah.
and we didn't really have like a lot of information, and they were like, predict what'll happen in like the next year.
Yeah.
And two of the answers were like so close to each other. I was like, this is you guys.
And that's the other thing, when you start taking those multiple choice tests like that, if you start looking at just the answers, you could probably answer the question.
Yeah.
And it's a test taking skill.
Like, yeah, like the last one was like 19, and they were like, predict what will happen in like 4 years or something
Yeah.
like that. It was 25 or 26, and I was like, this is stupid.
And then the other ones
Well,
are
I said
probably
both.
so off.
Yeah, there was like 50, and I was like, well, not 50.
And that's the idea, you have these
And
distractors.
there
and
was
things
one
like that.
below 19, I'm like, it's not gonna tip below 19.
And you're using an idea, so you whittled it down to like, well, it's gotta be either one of these, and you flip a coin and you go. But yeah, just remember, that's when you're looking at science stuff. Logistic is like a population effect. When you're getting to that packet then, when we're looking at the review jump that's on there, let's see if I can open that one up. Mr. Fontana put this together last year, and it works really nice as far as what do all the different graphs and things look like. I know that we've done linear, quadratic, cubic. Now, quartic. Quartic is a yes, sir.
Oh, will we get our calculator for the whole test?
Sure.
No.
Nice. When you get to what's called a quartic is a fourth degree polynomial. Fourth degree polynomials can have up to how many changes? Three changes of direction. So if I'm looking at this, it could also have how many possible zeros?
3.
Quartic.
Oh.
Quartic could have 4 zeros. If I'm looking at this, here's 1, 2, 3 changes of direction. So this is probably a quartic model, a quartic graph. It has a doubled 0 in the middle. Now, we actually wrote out equations before, given that information, given zeros. So just for fun. Oh, actually, this looks like it had a 0, 1, 2, 3, 4 zeros. So, so that had 4 zeros right away. It looked, when I said it, looked like it just touched the axis in one spot. I'd go with quartic. Now, when you're talking about the other one that was on there, what was it?
Tight quartic and quadratic and stuff.
Quadratic is squared, quartic would be fourth, so it's twice as much fun.
Yeah.
That's not.
I think everything's in the calculator.
Wait, what do you mean?
The only one that's not in the calculator, I believe, is the logarithmic one. So if we want to go back and think about how you graph a log. When we graph logarithms, let's look at just a real quick graph. Let's look at y equals, and let's just do something simple. Let's just do log of x. Oops. Logarithms had a vertical asymptote. Remember that?
Yeah.
They had a vertical asymptote and then they just took off. Okay. Whereas exponential ones, take a look at e to the x. Where is it? Had a horizontal asymptote. and went up. That was the difference.
Good.
Logarithms had a vertical asymptote, which
Would you
is
put
where
it
do
for
logs
Y2?
come from?
Would you put in for the
Trees.
second one?
And what do trees do?
Make
oxygen.
They stand vertically.
Wait, what?
There is method to the madness of the things that I talked about.
Wait, what was the second one you put in?
It's log, it's big, it's heavy, it's wood. Wood comes from trees. Trees stand vertically. Logs have vertical asymptotes. Yeah.
What's the second one?
E to the x.
Oh.
That's one of the ways of remembering the differences when you're looking at graphs. Yeah, Edgar, what do you got?
In our test, will they have the little dashed lines?
What do you mean?
Like, will
Oh,
they-
on the pictures here?
Yeah.
Yeah, if I ask you a question to identify a graph, I have to throw in an asymptote,
Okay.
because then you would know. Okay. So looking through these, they are pretty quick to go through. I don't think there's a logistic one on here, because some of the other one, I don't think the regular classes did logistic growth. I think we were the only ones. So, but that was really easy to tell. Now, when we get into these, when you're looking at deciphering what method it's what graph it's going to be, you can always use finite differences. Find out, do your subtractions. Those are going to work for all of your polynomials. Not so much for exponential, sinusoidal, logarithmic, or the other ones, but it will work for your polynomial. Finite differences will work for polynomials. Now, the other thing that to be honest with you, I didn't know you could do this. Let's look at 24 real quick, and let's put it in our calculator, L1, L2.
That.
So I'm gonna clear out your y equals real quick.
Good idea.
What number?
24. We'll clear all lists, and we'll go do a stat edit L1,
We're
L2.
doing 24.
Yeah, 24. It's 1 through 5. Okay.
Second plus. And then second plus 4.
Stat plus on. Now, right now my graph is just at a regular standard window, 10 by 10. I just found out there's a button you can press that it'll adjust to your data. I didn't know. Yeah, so you don't have to mess with your window all day long.
Wait, so what?
I know.
Thank God.
What is this button?
Thanks.
You named this button.
What is this button? Mr. Murphy. What's the button?
Zoom 9.
Nine.
I know.
Whoa!
Look at that. It automatically adjusts your window.
I need to write
Now, speaking of adjusting windows, if your car has an automatic power up on the driver's side,
Yes.
why doesn't it have it on all the windows?
'cause the-
How difficult is
I've
that?
been thinking
But
the
you don't want
same
your
thing
charger
my
messing
whole
with
life.
Just in the driver's main control
Yeah,
area.
like I just hit it and
Doesn't
I'm
need to
like,
control.
You can get automatic down for
the other
both
one's like a
windows.
hold.
My dad.
Ain't nobody got time for
My
that.
dad's new car has automatic.
That's why I make that
Some of them you can do that, but my wife's car is a 2005. I can do that with all of hers. Works great. My truck's a 14. Only do one.
You can only.
I don't.
Maybe
Oh, you have to manually hold down all the other buttons. I can't just press it once and just let
trucks
them all
don't
hold
want
down.
you controlling other people's air. It's Obama.
So now if I look at this graph, oop. I really messed this up. I don't think it's gonna work. If I look at this graph and I start to kind of mess around with it, what's that graph gonna be of?
1, 2, 3, 4. We're quadratic.
Quartic.
One.
Quartic, because you've got 3 changes of direction. And 1, 2, 3, 4 zeros. See that? That's a nice way of doing it. Or you could have done finite differences. It would have worked as well. Yes, ma'am.
Rich at 37.
37?
Just makes a lot more sense. I was so confused.
I messed this
I'm
up.
just struggling with linear cubic quadratic exponential power logarithm and sinusoid. That's it.
Excuse me. Thank you. 37. It looks like it wants to be exponential, I bet.
But it's like
Oh, okay.
It looks kind of, it looks
We're
like.
doing, we're doing 37.
37. Let's see here. Let me type it in the calculator to see what happens.
You are doing 37, correct?
Oh, I did 36.
I'll test it.
Talk yourself off.
Only thing you were only on their list.
Oh.
you missed zero.
Yeah.
Would you looky there?
What do I hit again? Isn't that awesome?
How did you discover that?
Fontana.
No.
Fontana knows everything about this calculator.
He does know everything
I
about the
talked to
calculator.
him once and he was like, all you gotta do is hit that button. I'm like, wait, what?
So they said this was. They said it was quartic?
Yeah.
This ain't quartic. What is that?
I'd say exponential. Well, how can we decide whether or not it is exponential?
Yes.
Natural log it. So if you go to your natural log, if I want to do the natural log, I would test it via the natural log.
Get out of there.
-1.
I'm stuck in the graph.
And I can't do
I'm
that.
stuck in the graph.
I can't do natural log of negative.
Also when you go to like
That's why. But then the idea here is, why is it going? So now we know that that won't work. Oop. So then you have to think about, okay. Then you go back and start messing around.
Let me see.
Zero.
What does it mean?
Wait, Mr. Murphy, what'd you put in the L3
Somebody
to
had
test
that a
it?
lot of time.
I put natural log was if I want, because to me right now the graph looks like it would be exponential.
Yeah.
But I can't take natural log of -1.
Is that all you do is put in natural log?
Yeah, and then it came up with my error right away, saying, oh wait, doofus, you can't take natural log of a negative. So that way we know it can't be an exponential function. Because if it was to give me an exponential, then I could graph it, it would look linear-ish. Remember the y value one?
All you do is hit natural log and then press graph?
Well, no, you have to natural log that whole column. But right as soon as I hit natural log of -1, it came up with the answer saying, hey, domain error is not going to work.
Oh,
So
okay.
it looks exponential, but there's one negative value that it
Yeah.
cannot give.
I don't know who it was though.
So,
No,
I
wait,
put
it's
exponential.
But it could have
test
it could have had a shift. Well, yeah. What's up?
If I put, so if I saw this on a test per se, and I put exponential, I'd be wrong.
Right. Because it's not with the data set. Do you want to plot it the other way?
So if there's one negative one,
Because our exponential ones that we're working with are just a b to the x. We don't have that h's and k's thrown in here. It's just a b to the x.
So it is.
automatically
So it is
quartic?
quartic.
this is.
Then we have to think about the curve through. How would you get? Then if you're going to go quartic, then you'd have to go and do your finite differences.
Can I just see
Which
it?
is like the.
It
Yep.
just says.
You would do your tree thing here, and if it's going to be a quartic, if you did it 4 times, you'd get the same value. So immediately looking at it, I think exponential. Then I say, oh, I can't do that, so then I have to check it with my. Then it'd have to be some sort of polynomial. Then I check my finite differences.
And then you have to do like the 3 columns and
Yeah.
then find like A, B, however many.
Yeah.
So what do you do after?
No, actually, once you get this data, once you decide that it's going to be quartic, if I wanted to write the, I'll get you 1 second, Edgar. Once you do your finite differences and you tried it 4 times, you don't have to do the column stuff because now your data is in here. There should be a stat calculate quartic, option 7.
You press calculate.
Yeah.
So that means that you would have to be able to calculate.
Is that my answer?
Right. Yeah. now that we know that we can get away with writing it out long form without having to do that, we just hit the regression button.
There's an E in there?
The regression button is just taken away from having to do the system of equations. Okay.
So, all the like negative, like, we don't have to do any of that.
Regression.
So, like, we
That's a
don't
real
see that at
jerk
all,
of a
we can just
problem.
use that on
Yep.
any of them.
Yep.
You just had to throw in that -1.
Then why didn't we?
I don't want to give away everything right off the bat.
So then after,
So when you're seeing the C, D, and E, everybody notice how that's like really, really basically zero?
we just plug that in,
I would call those zero.
all of them?
Yeah, negative. So my answer here would have been x to the 4th minus 2x cubed. And that would have been my model.
What is the?
So if
That means it's approaching zero. Those are just approximate
it's
zeros.
really, really close to 0.
Yeah. For what I would write for the equation for this then, oh, actually, if you also look at it, first order, second, determine what type of function, it's telling you to go, when it tells you use first order, second order, that means, oh wait, that means use finite differences. So right,
Can you explain what finite differences is again?
it's that subtractions.
So then if we
Ah.
subtract it 4 times, that means it's
Yep,
or if it's 3 minutes.
cubic. Yep.
And then 2 then.
Quite right.
When do we learn finite differences?
While ago. If I do this, what's 0 minus negative 1?
Okay, never mind, I know it.
I'm doing that right now.
And then you go through it.
Yeah, I can't remember.
Yeah.
Because I was looking at the wrong number. Ignore that.
You were.
Try to keep working through. We'll go through the rest of this stuff tomorrow. Remember, when you're looking at the word problems, they're kind of leading you to the modeling of it itself. Just remember the wording of it. Population growth is usually logistic. Anything that's replicated, like temperatures, waves, that's probably worked out, didn't it? It'd be funny if it was 6, 6, 6 all the way around the whole time.
Nope, it's just 24, 24.
Don't itch it.
I don't care.
Don't itch it.
Yeah, it's like ringworm, you can't itch it.
It just gets worse.
Don't itch it.
I'm rubbing it, I'm not itching it, there's a difference.
You guys just slap it.
Great on mosquito bites.
Slap it.